Okay, so for this question on plane geometry, they already have angle with algebra labeled for you already. So this question starts with an angle x. So it starts you with an angle x here. Okay, so look at the information first. Okay, the question mentioned about a diameter. Okay, why do we need to look at the information? Because it should lead you to think about some property. So for example here, because of the diameter, it will lead me to see the angle in a semicircle. Okay, then another thing will be, they mentioned about tangent. PT is a tangent. So I'm going to draw my tangent. So PT is a tangent. Then R is on the circle and the tangent to the circle at R. So there's also another tangent at R, which is here. So you need to take notes. Where is the tangent that they are mentioned? Okay, then QRT is a straight line. Okay, so first of all, when tangent is involved, and you can see that tangent starts from, the tangent is actually from the external point. So the property about tangent from external point will see that you get an isosceles triangle. And also, if there is a tangent, you should be looking out for tangent chord. So that is before you answer any part of the question yet. So it should generate some thinking in your head by offering you the information. Okay, and then finally, the question is asking you to prove in either order. So it doesn't matter. It doesn't matter which order that you prove first. You can prove it in order. Some people couldn't prove it in order. Some people, they have to go to RFT isosceles first. Then they can prove that RFT equal to 2x. So if you are like that, then it's okay because the question says it's in either way. So however, okay, one of the reasons why some students are stuck at part one is because they never see that it's a tangent here. They didn't see that it's a tangent from an external point. So PS and RS are actually tangent from an external point. So if you look SP, SR, they are tangent from an external point. And because of that, it's actually an isosceles triangle. And because of that, okay, these two will be the base angle. So if you realize that this is a tangent from an external point, the isosceles triangle will have make life easy. Okay, those who can see exterior angle will be able to tell that this is straight away 2x. Exterior angle of a triangle. So if you are very comfortable with the use of exterior angle of triangle, you can tell that RST is already a 2x after the isosceles triangle. However, if let's say you couldn't, you should at least be able to do an angle sum of triangle. So you should be able to do an angle sum of triangle. And then you do an angle on a straight line for RST. You will still get the 2x that the question wants. So if let's say you don't prefer the use of exterior angle of triangle, you can still go for the traditional way of angle sum of triangle, angle on a straight line, and that gave you the 3 marks already. But the requirement will be you see the tangent from the external point. So that is done already. So with that is done, you continue with whatever that we need for the second part. So we need to prove that this is the isosceles triangle with the 2x already. Okay, so we will need to find the two angles here separately. So I need to find these two angles separately, and if they end up being the same, then that will have the isosceles triangle. Okay, So what I did was, okay, so there is a tangent chord here. So if you realize just now I mentioned, so I'm given this angle x, and then this is a chord, this is a tangent. So this will be equivalent to the tangent chord. This will be equivalent to the tangent chord. And then we have a big 90-degree here. So I have a tangent chord, I have a big 90-degree. This big 90-degree is radius perpendicular to tangent. So you need to quote the reason, because they can be 90 for different reasons. So in this case, it's 90 because of radius perpendicular to tangent. So with this 90-degree, with this tangent chord, I will be staring at this big triangle. So I'm going to stare at this big triangle, and I'm going to find this angle through angle sum of triangle. So I'm looking at this big triangle, the black one, the 90-degree, the x, to find that this is 180 minus 90 minus x. So using the big triangle, I found out that this angle is 90 minus x. So I'm going to find another one. Okay, the other one will be this one. So how am I supposed to find this one? Previously, we mentioned that there's an angle on a straight line. So because of, not angle on a straight line, sorry, angle in a semicircle. So this blue 90-degree is due to angle in a semicircle. And there will be an angle on a straight line. So there is another 90-degree here. So there's another 90-degree there because of angle on a straight line. And subsequently, if you look, I can still be finding out this angle. I can find out this angle by doing 90 minus x, because the x was already accounted for in the first part of this question. So separately, these two angles are 90 minus x. And that's why RST is an isosceles triangle. So there's quite a bit of playing around, but I wouldn't say that it's very difficult because the properties are quite clean. You should be able to see angle in a semicircle, radius perpendicular to tangent, isosceles triangle, and then tangent chord theorem. So there's actually a lot of information that you can see, but you need to start off by reading first. When you read the info, then you process it, then logically then you will generate more things. And they set the algebra for you already. You just need to play around with the algebra. So however, when you write out the proof, you make sure that you account for every single thing. It can be as simple as angle on a straight line, as simple as an isosceles triangle. So you just account for it. Don't process your algebra or your thinking in your head, because it's a very simple question. Okay, so that is the plane geometry for this O-level batch.